Hello everybody, welcome back to While True Learn. In the last episode, we finished the section on recognizing cat pictures, and today we are going to continue on with the next section. Last time, if you remember, there was a link that opened up a page in a web browser that gave us 2 promo codes. One of the promo codes is for this wallpaper on the main menu, and then if we continue, the other promo code was for getting this new cat. So we had this cat before, and then we have this one, which is the 2-flower cat, which there was a button here, get a cat, and it gave us the promo code for getting this cat. So now we got a new buddy with us. Alright, let's go on to the tree, and we will continue with the story segment. You have reached the end of the epoch. Click on one of the banners to proceed further in the story. Bronze, silver, or gold? Okay, I'm gonna go for gold. Eliza first chatbot, cats, biology, and iRobot. Cat mail. So apparently I got a package, and the cat's looking at the package. Oh, there's a camera. A camera in the television, looks like. Okay, this should definitely work. So apparently I am starting to record the cat, and that would be my attempt to analyze what the cat is trying to say. Okay. Oh, apparently I hooked up the cat to Eliza. Cat says meow. Eliza says, what happened? Cat says meow. Eliza says, yes, meow. Repeat please. And the cat says meow. And it says the cat has been detected, so it looks like my detector is working. Okay, Rosenblatt Perceptron. Hey, so I've managed to make my computer detect the cat, but that beast is a complicated soul. It definitely has more to tell. Maybe it's time to go next level and start recognizing emotions. Ever heard of perceptrons? They were invented in the 60s to recognize written text. Everyone knows that everything invented in the 60s is awesome by default. The double helix, rock and roll, lava lamps. Also, you can maybe switch to dogs instead of cats. Decision trees work like magic for my Pluto. You can also hit the store and get that random forest node. A forest is more effective than just one tree. Error rate. Now for something completely different, perceptrons can actually learn and improve. Bad news, they also make a ton of errors on the way. The percentage of errors is shown on this icon. Use training mode to teach perceptrons and decrease the amount of errors. Okay. Mark 1 perceptron in the game. Okay, it has 20% error. It classifies different shapes, and I'm guessing every once in a while one of the wrong shapes falls through. Training mode, Perceptron reduces the amount of errors while trying to predict the shape of elements. In test run, Perceptron only predicts shapes. In the real world, Rosenblatt's Perceptron used in Mark 1. This Perceptron could recognize only simple linear dependencies, but it was enough to recognize English letters. Okay, so let's see. I guess I need to hook that up, but right now it has 75% error, so it seems like I need to run training. Okay, so now the error is decreasing, and it looks like at some point, okay, nodes on the field have reached their minimum margin of error. There's nothing more you can teach them. Okay, and then once this is trained, I can just run, and now the output stream doesn't require 100% accuracy anymore. 60% accuracy is good enough. Okay, that was just a simple tutorial on how to use the Perceptron. Let's go to dairy products. Hello, my name is Sam. I own a dairy products factory. My dream is to make the very best goods on the market, and that's impossible without high accuracy fermentation processes. Alright, off with fancy words. I want a program that would judge the quality of a product by its ingredients. We often make mistakes when doing it manually, and a lot of our products never leave the factory since we mark them as defective. We have the data, we just need the algorithm. Okay, so again, output stream 3 requires a bunch of circles. Okay, it seems like I could put the circles here and just give the other two to stream 1. Right now, let's run some training. Okay, and then 30, I guess so. Let's just test it. Okay, might be feeling too slow for the gold medal. Yeah, okay. So we'll want something more interesting. Oh, what if we made... They only require 40% accuracy, so what if we made... Can I like undo the training? I'm thinking if we have a higher error rate, then more of the... Or I guess not. Maybe more of these will in fact be sent to stream 3 instead. That's going to make it even worse. Let's try it. I want to stop at, let's say, okay, 34%, and then test. Okay, I guess that worked. I didn't really expect it to work, but I don't know if that was intentional either. But that seems to have worked, so release. RNG is my best friend now. Alright, metal gear construction. Okay, here, go learn how to detect the cat in the pictures. That's done. And Perceptron's good for pictures. Grandma probably used it. I don't know about that. Depends on how much computers Grandma used. Hello, we are the Metal Gear Construction Factory. We produce fittings and supply raw materials to construction grounds all around the world. We are especially proud of our high standards of quality. At the moment, we're receiving a lot of new orders, and we are running late with the deadlines. An algorithm is required that will analyze the quality of raw material and discard poor quality ore before it leaves the conveyor. Manual analysis takes way more time than we can afford. Okay, so colors, shapes. Okay, it seems like we only need 60% accuracy, so I'm thinking maybe we can fudge it by just doing all the reds and all the triangles. Okay, yeah. So let's do this. All the triangles automatically go in here. And then out of the other shapes, we will select the red ones. We don't want any other color mixed in though. 60% accuracy I don't think we can hit if we get too many bad hits. And we're allowed more nodes anyway, so it doesn't hurt to do this. So we want only the red ones. Let's pick out the red, and then pick out the blue. Trash these two, and then the red should go in here. Do some training to make our Perceptron good. let's test that. Okay, our accuracy is holding up pretty well. Not getting enough inputs though. Yeah, ran out of time. Okay, something is too slow. What's happening here? Oh right, the Perceptron is barely enough because there are also red triangles that are filtering in, and it's not liking that. Okay, let's try reversing the order. Okay, let's try getting only the red first. Oh, we don't want a trash can actually. So let's do red, blue, red, green. This way we'll only have red on top. And then out of the blue and green, we can process each of these to allow circles and squares. Circle, square, trash can, trash all the triangles. Maybe. Yeah, it's taking a while to train because there aren't a whole lot of green objects coming in here. Okay, one problem I see is a bunch of green items are dropping into this lane. A bunch of green items were dropping into this lane and it was plugging up this system. The queue was totally full. And I think that's going to take more time than we'd like. So, because we can use more nodes, I think we can use another decision tree here. So we have blue and green coming in here, and we want to filter out the green ones to make sure all the green ones go into the other Perceptron. Let's run the training again. I don't know if... okay, I guess it didn't... yeah, in the real world, if you train this using a subset of the green shapes and then you change the setup to give it a different set of inputs, this training might not be valid anymore, but I guess in this game it doesn't matter. Let's test that. So our accuracy is not doing very well. Nope, we are getting too many red triangles, I'm guessing. Okay, it looks like the rest worked pretty well. This lower part worked pretty well, it's just we got too many red triangles up here. Oh, I'm a bozo. I totally messed up the shape. We're supposed to get triangles over here, so I totally inverted the logic there. The squares and circles need to be trashed. Same thing over here. We want the triangles to be up here. That's why my accuracy was so bad. Yeah, because I was looking at the number of red triangles compared to everything else, and the numbers don't look that bad. It shouldn't be under 60% accuracy. Let's test that. We should have much better accuracy this time. Yeah, okay, accuracy is doing much better. Oh, still just a little bit slow. 28.7. Edit. Okay, we need 28.0, so just a little bit slow. Huh, okay. Seems like our accuracy was okay, so I'm wondering if we can fudge the outputs a little bit more, just to get more items in here and in exchange for lower accuracy. So these seem to be okay. I guess I can try to do the redo the training again, but the other thing I can do is just set this to any. So the purpose of this was to separate out the red ones and the green ones, and we were only sending the red ones this way. So now if we pick any and green, we will still get all the red ones, but we will also get half of the green ones, which are wrong, but it doesn't really matter because again, we're lowering the accuracy in exchange for more items. Let's try that. Alright, awesome. We got 27.4 out of 28. Okay, toy manufacturing. Let's go. Howdy, I'm contacting you on behalf of Nuka Toy Company. We design and manufacture toys for children using 3D printing technology. There are 3 types of raw materials we use for printing, and we need an algorithm that would distribute them correctly. Passing a certain error threshold could result in a disaster, so watch out for those. Okay, circles, squares and triangles, or any shape. Okay, the output stream 4 requires absolute accuracy. These two with shapes separated only require sort of medium accuracy. And we only have access to the Perceptron. I could try that. We need 30, 30, that's 60. We have more than 60 in this input stream, so we could do this. Connect the shapes to what we want. Oh, circle 25. No, we need 30, so that's not gonna work. I was thinking just do this. So everything goes here, that's definitely guaranteed 100% accuracy, and then divide the shapes over here, but no, we need 30 circles, which this doesn't have. So we need something a little more complicated. Okay, how about this? Since we need all the circles to go up there, let's make another one that essentially does the same thing, and then we'll send this output. Okay, let's see. Output stream 2 requires 30, output stream 4 requires 45. Out of the square and triangle shapes, this one has less, this one has more. So I'm going to put the source that has less into the output that requires less, and then the source that has more into the output that requires more. And then we'll need to train these perceptrons a little bit. Okay, let's test this and see how it goes. Yep, they're filling up pretty evenly, so that's a good sign. Okay, output stream 4 is just a little bit slow. Ran out of time, okay. Just a little bit slow, that means we need to put a little bit more into output stream number 4. Let's see what we can do. So this is receiving squares and triangles from here, 35 and 25. This one is receiving squares and triangles from here, 22 and 18. So, okay, this is already receiving kind of the minimum amount. I can't swap a higher number with a lower number here. That's not an option. So how about if I hijack some of the circles? So something like this. I'm going to put the circles over here. And then the rest of the shapes over here, and then I'm going to train this until this perceptron has an accuracy of, let's say, 50%. The idea is if it has an accuracy of 50%, then out of all the circles that come through here, half of them will be correctly detected as circles and they will go to the top node, and then the other half will be incorrectly detected and they will go to the bottom to help make up for the shortage that we were seeing. So I want to stop this until the stop this when the accuracy gets to about 50%. let's test this. Okay, that was complete, but the top one took too long to fill. So, okay, maybe we want to allocate more toward the top. So maybe allocate this to the top too. That way I'm guessing it's about a 75-25 split. Okay, yeah, now the output stream 0 and 4 are filling up pretty much at the same rate. Alright, we got it. 43.8, just below what we need. Okay. Today we finished this branch, we got gold medals on all of them. This is a good time to end the gameplay portion of this episode. Stick around if you want to hear some discussion about Perceptrons, or feel free to skip to the next video if you just want to see gameplay. In this episode, we got the Perceptron, which is a basic machine learning technique. As the name machine learning suggests, the Perceptron can learn or be trained from arbitrary input. This is very different from the techniques we've seen previously. Decision trees and SIFT are tailor-made for one particular purpose. In the case of decision trees, each tree can only handle whatever classification it's designed to make, and you'd have to create new trees manually if you want to classify new things. For SIFT, it only works for shapes and won't work for any other kind of input. On the other hand, the Perceptron can be trained to recognize arbitrary things. The game mentioned it was used to recognize English letters, but you can also use it for numbers, shapes, maybe even cats if you just give it the right training data. Another difference is these new machine learning techniques now don't have 100% accuracy anymore. Because they are trained with limited training data but then need to handle arbitrary inputs, there are always going to be inputs that are different enough from the training data that it just can't recognize properly. This shouldn't be a surprise because even humans sometimes misread or mishear things. In a couple of levels already, I've been cheesing this game by sending items to outputs that obviously aren't supposed to go there. That works under the game mechanics because those wrong items help fill up the output quota, and the game accepts them as long as the accuracy rating doesn't fall too low. But this isn't realistic. Margins of error are supposed to exist for honest mistakes, not intentional ones. I can't think of any real-world situation where you would intentionally put items into a batch when you know it doesn't belong there, even if your quality standards allow for a few bad items. In practice, sometimes you do trade off accuracy for processing speed, but that's more about the processing time within the node. You can have a node which can sort one item per second with 90% accuracy, or if you're willing to decrease its accuracy to 70%, then it might be able to sort 2 items per second. Sometimes this kind of trade-off might be worth taking. But again, that's totally not the same thing as taking the results from a node with 90% accuracy, then mixing in a bunch of known bad items to reduce the accuracy down to 70%, just to make it look like the node processed more items. And that'll be it for this episode. Hope you enjoyed. See you next time.